So we're going to do a few examples now. So I've written the questions down and we'll just go through them. How many ways can 6 blocks be arranged? So that's a keyword, arranged. So that indicates that it's a permutation or multiplication principle on a shelf if they are all different colors. So we've got 6 blocks, different colors. We're putting them all on a shelf. So 1, 2, 3, 4, 5, 6 spots for those, and how many choices for the first spot. So we go to the blocks, we pick up 1, and there's 6 there to choose from, so 6. And now there's 5 left, only 4 left, 3, 2, and then 1. You could multiply these all out, or you could say 6 factorial. And again, on your calculator, 6, second function in mine, and then the factorial button, 720. Okay, question 2 says, how many ways can 6 blocks be lined up if 2 are yellow, 3 are orange, and 1 is green? So here, what I've done is there's no longer 720 if you can't tell the difference between these. So if 2 are yellow, so you put a yellow and then a yellow block, or switch those around. The switching around would be counted in the 720, but we don't want to count that as 2 because yellow, yellow, and then say orange, 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 green is just one arrangement. If you flip the orange around, that would all be counted in here because they're different. Okay, so this is indistinguishable permutations like we did before. And so again, we've got 6 spots. So that will be 6 factorial. But we divide it by the ones that we can't tell apart. So for the yellow, it's 2 factorial, or 2 ways. You know, yellow 1 and then yellow 2, or yellow 2 and then yellow 1. So for every 2 yellows you see, there's count 2 different ways. And the orange is 3 factorial. 3 factorial is actually equal to 6. Right? And that's saying if we've got 3 orange and you numbered them so to keep track of where they are, there's 6 different ways we could put those. So 6 factorial is 720. This is 2 times 6. So 720 divided by 12. I've still got the 720 in the calculator, just hit divided by 12, and we've got 60. So that's quite a bit less than the first one. Okay, so here, suppose you have 5 math books, 4 English books, and 3 science books. So how many is that? 9, 10, 11, 12 altogether. So we've got 12 books, 5 are math, 4 are English, and 3 are science. It's just similar to the blocks, except instead of colors, I'm giving them a type, or a name, or a course. So A says, how many ways can they be arranged on a shelf if all the books are different? So instead of thinking it as 5 identical math books, they're saying all the books are different. So, and we want to arrange all of them. We said there was 12 books altogether, so you could write 12 lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 choices, 11, 10, all the way down. Or you could just say 12 factorial. That's a lot. Okay, and the next one says, how many ways can they be arranged if books of the same type are indistinguishable? So now we're saying that, oh, I spelled that wrong. Now we're saying that the math books are all the same. Instead of 5 different math books, we've got 5 all the same math books. So instead of 12 factorial, we divide by the ones that are the same. So for math, it was 5, so 5 factorial. English was 4, and science was 3. And I probably wouldn't write all of these out. I would type it all in. So 12 factorial. And then I would divide. And you could put a bracket and say 5 factorial times 4 factorial times 3 factorial. Okay, so 27,000 ways. Now the last one on this sheet says, if all the books are different, so going back to them being different math books, etc., how many ways can we arrange them so that books of the same type are kept together? Okay, so they're all different books, but we want to keep the math with the math books, the English with the English, and the science with the science. Now this seems like it won't be too difficult, but it's 2 steps to this. So first, let's say if we want types to be together, and there are 3 types. So let's give it 3 spaces. These will be the math, these will be the English, and the science. And let's just see how many ways there are to arrange that. So the books are all different, so the math books can be arranged 5 times 4 times 3 times 2 times 1, or you could write 5 factorial there. The English books, there are 4 of them. So the first spot, 4, next spot, and going down, and the science is 3. So 5 factorial times 4 factorial times 3 factorial. Now this is not the answer. So what are we missing? I did keep the books together and I did arrange them, you know, the math, the English, and the science all together. The books are all different, so we need to make sure we count them all. But they don't have to go math, English, and then science. It could have different arrangements. We could say English, math, and science, or science, English, math, and those would be different ways that you would see the books on the shelf. So we actually not only have to count the individual books like we just did, but we have to count how many ways there are to arrange the subjects. So you could just write out the ways and count them, because there's only 3, and if you were writing them out it wouldn't take too long, but there are 3 spots. How many choices do we have for the first spot? Well, when I wrote this down earlier, I did exactly that. I could have written math, English, or science here. I chose math just because it was first up above, but I did have 3 choices. And then once I chose math, I could have put either English or science in that second spot. I had 2 choices and then 1, so that's 6 ways. So for each of these, let's get what this number is. Okay, so for 17,280, there's 6 different arrangements I could have that each have 17,280. So there are 6 of these 17,280. So 103,680. So you have to sort of think of all the possibilities, and these 6 ways are how to arrange the subjects. Okay, so part D, if all the books are different and science must be first, how many ways? So this is saying that science does have to be first, and then the other 2 are here. So this is one choice. We can put science there. And then this can be either math or English. So that's 2 choices, and then the other one left. So there are 2 ways to arrange the subjects. Only 2. Where last time we had 6. We can have science, then math, then English, or we can have science, then English, then math. These are the ways to arrange the subjects, because we said science has to be first. Oh, wait, I'm wrong. Okay, I would be right if it said the other subjects had to be kept together. So now I'm noticing that I didn't actually write that. I said if all the books are different and science must be first, how many ways can they be arranged? So we don't need to think of this. We just have the science books first and the other book second. It's a bit tricky. It didn't say that I had to keep math with math and English with English. Now I could have worded it that way. What might I have said? If all the books are different and science must be first, followed by the other two subjects kept together. Something like that. Okay, so science, how many science books were there? 3. So, and all the books are different, so 3 choices, then 2, then 1, or 3 factorial. And the others, there were 5 math and 4 English. So there's 9 others, so this would be 9 factorial. So 3 factorial, the science, and then 9 factorial. Okay, so let's just take this. I'm just going to get a different marker. This is not part of it, so if you were looking back, oops, this we didn't need, although we could have worded a question that way. You know, if we said the other subjects had to be together. And then we could continue on with this idea. So there's 2 ways, and then the subjects together. So you have the science, which is 3 factorial, then the math, and then the English. Oh, science, let's say English, and then math. Doesn't matter the order, right? And then there's 2 ways I could do that. It's or science, math, and English. And that's the 2 ways that I got up here. So the answer would be different for this. It would be 3 factorial times 4 factorial times 5 factorial, and then twice. Add it to the same thing, or times 2. And of course this is more restrictive, so the number is smaller, where this is more open and the number is bigger. Okay, and the last one for this video. Suppose the books are indistinguishable, so we cannot tell them apart, and subjects must be kept together. How many ways can they be arranged? So, subjects must be kept together. So we said that before. If you arrange the subjects first, there are 3 choices for the first subject, 2 choices, and then 1. So there's 6 ways to arrange the subjects. Now they're indistinguishable. So if I'm putting whatever subject here, let's suppose it's science, and there are 3 science books, but you can't tell them apart. How many choices are there? If you know the science books are going on that spot, so you have the science books over here, here they are, book 1, book 2, book 3, they're identical. When you put them on those spots, it's just going to look like that. Science, science, science. It's just one way. You just put them on the spot. If you pick them up and move them around, you can't tell the difference. So there's only one arrangement. And then say math, again, only one arrangement. They're indistinguishable. So there's 6 ways to do it in total, because this is just equal to 1. When you're counting like the 3 or 4 or 5 factorial for each book, that's when they look different. So you're looking at an arrangement on the shelf, and you might have this science book that's biology, a chemistry book, and a physics book. And there's 3 factorial ways to arrange these. You could put biology, chemistry, physics, or biology, chemistry, or physics, chemistry, or chemistry first, and arrange them. That's 6 ways, if you can tell them apart. But if these are just, say, science, Science, they're the exact same book. It doesn't matter if you move them around, it still looks the same. So there's only one way for that to appear on the shelf, and that's what this is talking about. Okay, so I hope that helps. We'll go to the next video.